Hey everyone! In this video I'm going to show you how to use the zero property to find the x-intercepts from the factored form of a quadratic function. Okay, that's a lot of terminology all at once. Let's just jump right into an example because I think it'll make more sense if I show you what I mean. So let's say we've got f of x is x plus 4, x minus 6. As you saw from our last video, that gives us two different zeros. Our first zero is going to be negative 4, right? Don't forget that when you move that 4 to the other side of the equation, it becomes negative. And this negative 6 becomes a positive 6. Sorry, I realized I forgot a key detail the first time I recorded this. How do we turn these two values here into points on a graph? The idea is that negative 4 is an x value, and our function, remember, spits out y values. So negative 4 is a zero of this function, which means it's going to make the function give us a value of 0. So negative 4 comma 0 is going to be 1 point, and 6 comma 0 is going to be the next point. So I'll show you how to graph this right now. So we don't have much yet, but we can sort of start our sketch with a 0 here at negative 4 and another 0 over here at 6. Now, this next part is the real critical part. We know that every single quadratic has a vertex. We also know that every quadratic function is symmetrical. So we don't know what it is yet, but we know that there has to be an axis of symmetry, and somewhere on that axis of symmetry there has to be the vertex. So this is our axis of symmetry. Okay, so how do we find that value? Well, that value has to be in the middle because it has to be symmetrical. So we need to average negative 4 and 6. So we could do this sort of the long way, which is to, add, if you're averaging numbers, you add them up and you divide by the number of numbers you have. So we've got two numbers here. So negative 4 plus 6 is positive 2. Positive 2 over 2 is 1. So our axis of symmetry is the line x equals 1. So that means that our vertex has to be on this axis of symmetry. We have to have a value of 1 for the x value of our vertex. So let's take that value of 1 and plug it into our functions. So I haven't showed you guys this yet in this course, but you might remember from last year that function notation lets you show the value that you're substituting by putting it into your function instead of x. So that means that we have 1 plus 4 and 1 minus 6. So 1 plus 4 is 5, 1 minus 6 is negative 5, so this is negative 25. So the vertex of our parabola is the point 1, comma, 1 because that's the x value we subbed in, and then negative 25 for our y value. So our parabola is going to look something like this. And there's actually one more critical point that we can label, this point right here, the y-intercept. We can figure out fairly easily because the y-axis is the line x equals 0. So you can find your y-intercept by subbing x equals 0 into your function. So let's do that. So f of 0 is the y-int, and in this case f of 0 essentially means wherever, what's going on? Okay, here we go. Wherever x is in our equation, you just ignore essentially. So I'll show subbing 0 in for x, but really you can ignore the x entirely and just essentially multiply your constants. Positive 4 times negative 6 is negative 24. So f of 0, which is our y-intercept, is here at negative 24. And there you have it. We've sketched this quadratic with all of the most interesting points, the points we generally care about the most. The vertex, both x-intercepts, and the y-intercept. All right, let's try a slightly trickier example. Okay, now first thing I've done here is I've changed the f of x to a g of x, so you know it's kind of a big deal, this function. Seriously though, we've added something in front called an a value. We'll talk a lot more about a values later on in the course, but we'll see how that affects our vertex and our y-intercept in a little bit. And our two factors here are going to give us some fractional values. So this negative 1 becomes positive 1 over our coefficient of 2, and this one here, x is going to be negative 7 over 2. So let's start our sketch. Maybe I'll do it on the right-hand side just to be different, with our x-intercepts, -7/2 and 1/2. All right, so now we need to find our vertex. So in this case, we actually need to average our 1/2 and our -7/2. And I'm going to show you guys the hard way to do it and the easy way to do it. So the hard way to find the x value of our vertex is to just literally do 1/2 plus our -7/2 and average them by dividing by 2. So then this ends up being -6/2 divided by 2, which is -3/2. Okay, that's fine. The other way you could do it, if you've got some stronger mental math skills, you could just know that since it's over 2 and over 2, our final answer is going to be over 2 if you average them, and then just average 1 and -7. And I find that a bit easier because you can average 1 and -7 possibly in your head if you've got the mental math skills for that. So that means our axis of symmetry then is going to be x equals -3/2. Right? Because that's exactly halfway between our x-intercepts. So next step, we need to find our vertex. So our vertex is going to be -3/2, and then the value from our function at the point -3/2. Okay. You guys haven't seen this notation before, but essentially this is my x value and then my y value, which is going to be my function, what my function returns with the x value of -3/2. So we're going to have to do a little bit of algebra here. So g of -3/2 equals -2 of 2 times -3/2 minus 1. 2 times -3/2 plus 7. Okay. Now, this seems kind of scary until you realize that the 2 and the 2 is going to cancel there, the 2 and the 2 is going to cancel there, which means really this first bracket here is just going to be -3 minus 1, which is -4. And our second bracket here, because the times 2 and the divide by 2 cancels, just -3 plus 7, which is +4. And the -2 in front we haven't done anything with, so it's just chilling. So this is just negative times negative is positive, 4 times 4 is 16, and double 16 is 32. So our vertex, g of -3/2, the y value of our vertex is at 32. So let's plug that point in up here. So this is -3/2, comma 32. That's our vertex, and so we can fill in the sketch of our parabola now. It's going to look something like that. The last interesting point that we can figure out from this form fairly easily is the y-intercept. Now the y-intercept is on the y-axis. The y-axis is the line where x equals 0. So to figure out our y-intercept, we are going to need to do g of 0. Now I'm going to skip the step of my x things. I know that this 2x is going to disappear because 2 times 0 is going to be nothing. So really all I care about is the -2 in front, the -1, and the +7. So this is going to be -2 times -1 times +7. Negative times negative is positive. 2 times 7 is 14. So there you have it. We've got our x-intercepts, we've got our y-intercept, we've got our vertex from factored form using the 0 property.